Hello, everybody. Oh, that was too loud. Good evening. First of all, I would like to thank you all for being here and spending your Thursday with us. I would like to take a moment to thank Workfront Armenia for sponsoring today's event, and of course ISTC for hosting us. So actually, this is the second time that we're hosting an engineering meetup here in Yerevan. And we decided to create a platform where software engineers could come together and talk about technologies they're currently interested in and passionate about, or just working with those currently, and kind of share their experience, thoughts, ideas, and expertise. Also a place where people could talk about do's and don'ts or best practices of certain technologies. We also have a Facebook page. It's called Tech Talk Yerevan. If you're on Facebook and you didn't came across it, check it out, like and follow, because we're going to post the upcoming events there. And we also post photos there, so you may find yourself in there also. So today we have two very honorable guests, Matt and Ryan. They are both super exciting and talented people who currently work at Workfront as principal software engineers, and they are actually part of our architecture team at Workfront. Today's topic of discussion is going to be deployment of microservices. According to the agenda, Ryan will kick off with a quick demo of deploying a microservice to Kubernetes, and then Matt will talk about atomic microservice deployment. After that, we will have, I guess, half an hour for Q&As and socializing and some food. So enjoy your evening.
Hi, everyone. How's everybody doing today? My name is Ryan Orth. I'm an application architect at Workfront. Matt and I, we came from Utah. We've been here for the past week with our colleagues here in Armenia. Today I want to talk to you about deploying microservices to Kubernetes. My main goal of this is to show to you how easy it is to get started with Kubernetes and how it can really make moving to a microservice architecture a lot easier than you might imagine. So let's go ahead and get started. So first, let's talk about the motivation for this talk. The primary motivation is to dispel any myth that the Kubernetes is hard to learn. When I first started learning Kubernetes, I thought it was incredibly difficult, or I thought it would be incredibly difficult. The reasoning is partly because of the word. The word Kubernetes is pretty big, right? I mean, anything that's long has to be pretty hard. But to me, it was really more just moving out of my comfort zone. I'm used to working in a monolithic architecture where everything's kind of done a certain way. Kubernetes to me was kind of a new frontier and something that I wasn't sure how it would work. So as this talk is labeled, it's deploying something in 20 minutes. So if I can do something in 20 minutes while I'm talking to you, it's obviously not as hard as it sounds. The next motivation for this talk is to demonstrate how we can use continuous deployment pipelines that we can easily integrate with Kubernetes. In this talk, I'm going to be using GitLab, their CI/CD pipelines, but you can take this and extrapolate it over to any other CI/CD pipelines you use, such as Jenkins. And finally, I want to be able to show off the Kubernetes ability to handle and recover from any failure with zero downtime. So I hope through this talk you'll be able to see that Kubernetes is able to recover from failure when something goes wrong, and it does so in a seamless way, and that the end user has no idea. So let's get started and say, what is Kubernetes? So Kubernetes is a cloud-agnostic container orchestration framework that was developed by Google and later open sourced in 2014. So that first sentence has a lot of buzzwords in it, as I like to call it. So let's break it down. Does anybody know what cloud-agnostic means? Anybody want to raise their hand? Sure. What, what do you think it is? Sure. Exactly. So it means that we can deploy a Kubernetes cluster to any cloud, anywhere. So we can deploy a Kubernetes cluster to AWS, we can deploy it to GCP, we can deploy it to Azure, we can even deploy a Kubernetes cluster on premise. So we could deploy this to a server that you have running on a server closet in your office. When we say that it's a container orchestration framework, what that means is that we have multiple Docker containers running, and we want to be able to orchestrate them or have them communicate and become reliable in a manner that we trust that they are always running and able to communicate with one another. Kubernetes is declarative in nature. This means that it relies heavily on YAML files where we tell the Kubernetes master nodes, this is what I want my application to look like. We declare to it, we say, this is what we want our application to look like, and it ensures that the actual state of our application matches the expected state that we tell it to be. It relies heavily on the concept that everything is ephemeral, so you should never assume with Kubernetes, well, almost never assume, that anything is permanent. So this may seem kind of strange, but it really gives us some interesting properties. The really interesting properties that we get by assuming that everything is temporary is it allows us to build services that are incredibly available and scalable. This seems probably counterintuitive at first, but I hope that through the rest of this presentation this will become a little bit more clear as to how we gain higher availability and scalability by assuming that nothing is permanent. So who here is familiar with Docker? So I'm going to just go over some basic tenets of Docker because Docker is really important to understanding Kubernetes. So Docker allows us to encapsulate applications that we build into what are called images. Images are built use what's called a Docker file. A Docker file is a declarative configuration where we say this is what we want our application to look like when we run it. All Docker images are based on other Docker images. So if I'm deploying something, let's say, on a Node.js application, I'm probably going to base my Docker image off of something that already has the Node.js runtime installed. So all I really need to do is copy my application files over to the Docker file, and then it has everything that I need. An instantiation of a Docker image is called a container. So you can think of this if you understand object-oriented programming or something like Java as a class and instantiation of a class. And then finally, the reason that we use Docker is because it really allows us to run the same code in a consistent fashion everywhere. So I can take a Docker container and I can run it on my laptop, or I can run it on Kubernetes, or I can run it on somebody else's laptop, and it will run all the same, where you don't have the problem that you probably encountered in the past, where you deploy something and it works on your machine, but it doesn't work somewhere else. So now let's talk at a 10,000-foot view, at a very high level of what Kubernetes is and how it works. So there's a lot of diagrams out there that really explain how Kubernetes works, and they're all very informative. Very few of them I found are simple enough to really understand how it's working without seeing too much detail in the end. So what I have here is just a very simple, maybe oversimplified diagram, but I think if you understand this, you'll understand probably 80% of what you need to know to understand how Docker really works, or Kubernetes really works under the hood. So to start out, we have what are called master nodes. Master nodes you can kind of think of as the brains. You can think of them as workload coordinators that you communicate with and tell them this is what I want my application to look like. You also have worker nodes. Worker nodes are what actually run your Docker containers. Now, we're using this word nodes, and you may be wondering, what's a node? I mean, I've heard of node, but I don't know what that is. At the end of the day, it's just a virtual machine. So it's a virtual machine running in the cloud. So in the case of AWS, a master node and a worker node, they're just EC2 instances running in AWS that are running Kubernetes software. In front of the master nodes, you have what's called a Kubernetes API endpoint, and this is just a load balancer in front of the master nodes. So every time you make a call to it via the command line or via some other means, maybe the API, the Kubernetes API, it will just load balance between the master nodes. The way you typically interact with Kubernetes is using a tool called kubectl. It's also pronounced kubectl, but you can pronounce it however you want. The typical workflow is, as a developer, I will have this YAML file or this declarative configuration that I will issue a command and apply it to the Kubernetes API endpoint. This will then issue the command down to one of the master nodes, load balancing between them, and the master nodes will interpret that configuration that I've given to Kubernetes, and it will it will go ahead and send the different workloads down to the worker nodes to actually run your application. So that's a very high level, very abstract way of explaining how the Kubernetes cluster works in reality. So now we're going to talk about the idea of a typical service in Kubernetes. So if you go to deploy an application in Kubernetes, what's it actually look like? How is it architected? So we talked about master nodes and API endpoints and worker nodes, but for now, take master nodes and API endpoints and kind of put those in the back of your mind, because we're going to focus on worker nodes right now. A worker node has what are called pods running on it. A pod is really the lowest level thing that you can have in Kubernetes, and a pod in its simplest form has a single container running within it. That being said, pods can have multiple containers running in them, but it's not really common. There's more advanced use cases where this can happen, but for the rest of this presentation, just consider a pod and a container to more or less be the same thing. You can also have more worker nodes, and they will have their own pods running. At this point, if you want to expose your application running in Docker containers or in pods, what you would do is you would have a service. This exposes the application within the Kubernetes cluster itself. The service is really just a load balancer internal to the Kubernetes cluster, so when you make a request, it will load balance between the different pods in a round-robin fashion. At this point, however, if I were sitting at my laptop and I tried to hit my application using an API client or maybe my browser, I wouldn't be able to, because it's only internal within the Kubernetes cluster at this point. If I want to expose it outside of the Kubernetes cluster, I would create what's called an ingress. There's a few different ways to create an ingress, but the simplest way is what we're going to show in the next demo. So what this does, as I said, is it exposes the service outside the Kubernetes cluster. This ultimately allows me, as an end user, to access my service, which will then delegate or serve the traffic down to my pods, which will manage the workload and send the response back up to the end user. So I mentioned in one of the first slides that in Kubernetes, we kind of want to treat everything as if it's temporary or if it's not going to be there forever. And therefore, we kind of want to treat it as if it has no state, or at least little state. And the reason that that can lead to good things, such as high availability and high scalability, is let's consider the case where one of these pods, for whatever reason, it stops serving traffic. Maybe it can't connect to his database. Maybe it just crashed. Maybe something bad happened. In that case, it goes away, right? The good thing is pods have the ability to have a built-in health check, in which case they can report to the service, I'm no longer healthy, don't send me traffic anymore. In that case, you can see the service is now load balancing between the 3 remaining pods, and the end user has no impact. If we take this a step further, I had also mentioned that nodes are just virtual machines. If you've ever worked with virtual machines before, you know that they're just computers running somewhere, right? Which means they can go down, they can be deleted, they can have a natural disaster in the area causing the virtual machine to go down. So if that goes down, the service automatically realizes that those pods are no longer there and will stop serving traffic. As you can see, we went through 2 failure scenarios where we had an individual container or pod go down and an entire virtual machine go down. And because of the ability to scale horizontally and not maintain state, the end user would never notice because we still have a pod running. And we're going to demo that coming up. So now now that we've done a high-level overview, let's kind of get to the meat of this presentation. Let's try and deploy a microservice in 20 minutes or so. This is our improvised mic stand. So, can everyone hear me okay? Okay. So let's start by looking at the application itself. I've already built this application. It's 25 lines. It's very simple. If you look at it, it's just a Node.js application running an Express server. So it's pretty basic. And a little background, I've never been to Armenia before. Like I said, I'm from the United States. And so as part of this, what I wanted to do is I wanted to learn a little bit more about Armenia. So what I did is I have a Google Images NPM package that I'm relying on, and I'm providing it an engine ID and API key, which is more or less just the credentials to Google so that they know who I am and why I'm calling them, or basically just authenticate with them. And whenever I hit the root endpoint, I will simply do a client search for the query prefix, which is Armenian, and then a user-provided query maybe like culture or food, and it will do a search for Armenian food or Armenian culture, whatever it is I provide, and it'll return a list of images. It will then pick a random image. I think 50 are returned. It picks a random one out of all of those, and it will present it to the end user. So it's really simple. It's something that obviously you'd never build for your customers, but that's not really the point. The point of this is to show you how Kubernetes works and how easy this is to deploy to a Kubernetes cluster. The other thing that we're doing here that you probably would never do is you actually have the pod name and pod IP that you're going to expose to the end user. And we'll show that in the demo. And the reason I'm doing that here is so that you can see underneath the hood how we're actually accessing different pods every time we load the page. So now that you have a basic understanding of how the application works, let's go ahead and build a Docker file. So as I mentioned, a Docker file is used to actually load the application or actually build a Docker image with our application inside of it. So the first thing I'm going to do is I'm going to create a new file called Docker file. And in this presentation, I am going to be doing a lot of copy and pasting, but I'm going to do my best to walk through every line or most lines to give you an idea of what it's doing. So the first thing we're doing in this line or in this file is we're saying that we're building this Docker image from a Node 8 image. So as I mentioned in the previous slide, every Docker image is more or less based off of another Docker image. Because I'm using a Node application, it makes sense to build my image off of an existing Node image. So the first thing we do is we say we're building our application from Node 8. We then copy everything that's in this directory over into the Docker image. We run an npm install to install all of the dependencies that this application has. We expose port 3000 because that's the port that our application is running on. And when the Docker container actually starts, we run an npm start. So it's pretty straightforward. There's nothing too complicated going on here. So hopefully that makes things pretty clear. Now, at this point, all we have is a Docker file. We don't have a Docker image, which means we can't create a Docker container. And so what we're going to do is we're going to build a GitLab pipeline to actually build the Docker image so that it can be used in Kubernetes. So to do that, GitLab uses a special file called gitlab-ci.yaml. This is a reserved name that GitLab uses to know that this is the file that contains all the information about your CI and CD pipelines. So it's just a special file name. So let's go ahead and save this. And again, I'm using GitLab here, but you could extrapolate this and use Jenkins or any other CI/CD framework that you choose to use. So let's go ahead and copy from here. If you look here, we have a single stage in this CI/CD pipeline, and that stage has a single job in it called build. It's pretty simple. Really all this does is it logs into Docker, and then it executes Docker build and builds this Docker image, and then it pushes that Docker image up to the repository. So it's really straightforward. That's all it does. So if I push this up, we'll see they got pushed up to GitLab, to my GitLab repository. If I go over to the GitLab repository and I look at my pipelines, I think I clicked on the wrong thing. There we go. You'll see that it kicked off the job, and it's running it right now, and it's the build job. All it's doing is building my Docker image. Vlad, what do you do to this? Well, we'll go ahead and come back to this. But essentially what this is going to do is exactly what we defined in that script, where it builds the Docker image, and then it's going to push it up to the repository. So this is just pending. We'll see what's going on. But we'll continue through the rest of the presentation. So we have a Docker image, but we haven't actually done anything with Kubernetes yet, right? So the next step is to build a new stage in our GitLab pipeline. We're going to name this deploy. Again, we're going to copy over from here. And this is pretty readable, pretty declarative, so hopefully it's straightforward as far as what it's doing. So what this does is it creates a new stage called deploy, or a new job called deploy, and it's in the deploy stage. It has a dependency on build, which means that it's actually going to which means it's actually going to wait for this job to finish before it executes. Now this actually isn't going to run yet because the script runs a deploy bash script. The deploy bash script, however, doesn't actually exist yet. So we actually have to create it. That's pretty straightforward. Save it. We'll make it executable. And we'll go ahead and copy over the contents. So, is anyone here not familiar with bash? Or not familiar with deploying? Okay. So, in the script, essentially what we're doing is we're going to make a directory called .cube. This is a well-known directory for Kubernetes that knows to fetch its configuration. We then have a GitLab environment variable that we have stored in the repository itself. Not actually in the repository, but as a secret in the repository. And we export, or we echo that information into a kube config file. What this does is this is where Kubernetes knows this is where I get the credentials to log into the cluster or make calls to it. If I didn't do this step and I tried to execute this kubectl command down here, I would get unauthorized saying, you can't log in, I don't know who you are. This next step, we're actually going to echo a Google Engine ID and Google API key into files. The reason we're doing that, if you remember when we go back to this index.js, we need an Engine ID and an API key to supply to the Google Images client so that we can make calls to get an image from Google. Save that. And finally, now that we've echoed these into files, we can execute our first Kubernetes command using kubectl. And what we're doing here is we're creating a secret. The Kubernetes secret is a place that you put something that maybe you don't want in your repository. Like you don't want to put passwords or user information or things like that in your code base yourself. So you want to put in a Kubernetes secret. And what the Kubernetes secret is used for is for loading this information into your containers so that they can be referenced as the application is running. So what we do here is we have to execute a kubectl create secret, and we're creating the secret named Google Creds, Google Credentials, and we're using the two files we created in the line above, Engine ID and API key. We then remove those files because we don't need them anymore, and so now we have a secret. Our next step is to run a kubectl apply, and we apply a file called k8s.yaml. Now we don't have a k8s.yaml, but this is really where we have that declarative configuration saying this is what we want our application to look like. So if I go in here, I save it, and create a k8s.yaml. K8s, by the way, as I mentioned, kind of jokingly, Kubernetes is a very long name. So for those of you that aren't aware, K8s is the shortened version of it because there's 10 letters in Kubernetes, so you say K8 and S, so it's 10 letters total. So you'll see that common if you're Googling things or looking things up. So here we're going to go ahead and copy this, paste it, and as you can see, it's just a declarative configuration using YAML. You can also use JSON, but typically the Kubernetes community frowns upon it, typically because they just prefer YAML, and that's what you'll see most of the documentation and examples using. So the first thing we see is we're going to create a deployment. Now, in the slides, we didn't talk about what a deployment is. Really, a deployment is what's known as a replication controller, and all it does is it defines the number of pods that we want to run. In this case, we're saying 3, and it says what the pods should look like. So in this deployment, we're saying we want 3 pods to run, and they should be identical, and each pod should have a single container in it. This container will have the image that we created in the last build, assuming that it finished in GitLab, and we'll be exposing port 3000. The reason it exports port 3000 or exposes port 3000 is because that's what port our application is actually running on. The rest of this is just expressing different environment variables we want to expose to our pod. The first one is the engine ID, and that, again, is referenced here. So you can see we're doing a process environment engine ID, and that is fetched because we're declaring it right here. And these other environment variables are used by our application as well. But you'll notice the engine ID and API key, the secret that we created in the deploy script here called Google Creds that has the engine ID and secret ID are loaded in. And the way they're loaded in is by using the secret key ref. We're saying use the secret Google Creds and use the API key, or use the key API key. Similarly, it will do the same thing for engine ID. Now, pod name and pod IP, those are just metadata on the pod itself. And as I mentioned before, we're really just loading it in so that we can show the end user, you guys, what pod we're hitting underneath when we actually access our application. And that's more for illustrative purposes than anything. You would probably never do that in a real application. So now that we've talked about deployment, which is really just a set of pods, we're going to talk about some other terms that we discussed in previous slides. So you have the pods, and above that you have a service. The service itself is what exposes the pods as a load balancer within the Kubernetes cluster. What we're saying here is that the service is named Microservice Demo. It has the pods underneath it should have a label of app and a value of Microservice Demo, which ours do, which means that these are the pods that will be underneath our service. That's how it actually matches them, is using labels. And it exposes on port 3000. Pretty straightforward, but as I mentioned before, at this point, you couldn't actually see this application outside the Kubernetes cluster. In order to do that, you have what's called an ingress. Here we have an ingress. We're naming it Microservice Demo just for consistency. And we're saying that this ingress should be on microservice.demo.wfkits.com. What that means is when we hit this endpoint, it will send the information. It will relay the request to our service name Microservice Demo, which is our service up here, on port 3000. So that's really it. We built a Kubernetes application. We're going to deploy it, and we'll see it working. So let's go ahead and push this up. So let's go ahead and push that up. It should just take a second. And as you can see, that job finally finished. Vlad, I don't know what you did, but I really appreciate it. Vlad, by the way, is our DevOps guy, and he manages our GitLab pipeline, so I'm sure he did something special to get it to work. But essentially what this did is this just built our Docker image from a few minutes ago. So as you can see, this is waiting for a minute, and it built our Docker image, which was already built before, so it's kind of a redundant step. So it's going through that, and then finally it's going to deploy our code running that deploy script that we just built, where it pulls down, or where it sets the Kubernetes configuration file and the kube config file so that Kubernetes knows that we're authenticated. It's going to create the secret with the Google credentials, and it's going to run that kubectl apply k8s.yaml. And that's really what's going to apply and deploy our Kubernetes cluster. So as you can see, it's done, it's deployed. It should be all green check marks if we go back here, which means it's successful. So now let's actually see what the application looks like. So if we go over here and refresh this, hopefully it works. So there you can see, I'm querying for food, so I got a random Armenian food. If I scroll down a bit, you'll see that it shows me what pod I'm actually hitting when I access this service. If I refresh this, what we're going to see is it hits a different pod. It's going to get me a different Armenian food just because we're querying random images of Armenian food from Google. Let me refresh. It gives me another Armenian food, and it hit a different pod. If I refresh again, it's going to hit a different pod. So you can see the IP address is changing every time I execute, right? So every time I execute this, it's going to hit a different pod, and it's going to cycle through them. If you remember, we had 3 pods running. So because we had 3 pods running, we're going to hit a different one every time we rotate because the service delegates and load balances between all 3 of them. The next thing I want to show is actually what it looks like, what the pods look like. So if I look all the pods that got created using the kubectl command line, I see that I shouldn't have done that. I see that I have 3 pods, and they've all been running for about a minute and 20 seconds. So in order to demonstrate the high availability that Kubernetes gives us, let's go ahead and delete 2 of them. Go ahead and wait for that to finish. Delete those 2 pods. If I come back over here and refresh, you'll see it still works because I still have 1 running, which means we have high availability, right? So you'll notice at the bottom, the pod IP that I'm hitting is 100.96.5.17. So that's cool. That must be the pod that I didn't delete, right? But if I refresh again, we'll see that I actually get a different pod IP. So it's hitting 100.96.6.16. If I refresh again, I'm going to get a different pod IP. So this is really strange, right? Because I had 3 pods and I deleted 2 So I should be hitting the same one every time, but I'm hitting 3. So if we run this kubectl get pods again, you'll notice that we now have 3 pods running again. One of them has been running for about 2.5 minutes, and the other 2 have been running for 47 seconds. Those 2 that have been running for 47 seconds were automatically recreated by Kubernetes because it noticed that we said we wanted 3 pods, but we only had 1. So Kubernetes automatically recreated those pods, which brought us high availability. So as you can see, this is how, by treating our infrastructure as being ephemeral or temporary, allows us to scale. Well, not necessarily scale in this case, but become highly available to the end user. So that's it. I mean, we built a Kubernetes application and deployed it, and built the Docker image, deployed it to Kubernetes in, I don't know, I wasn't timing it, but it was probably about 20 minutes. And let's recap what we did. So we built a Docker image, and we built the Docker image that was used by our pods that we deployed to our app, to the Kubernetes cluster. Created a Kubernetes secret for storing the sensitive data, the Google information for accessing the Google client. We created a Kubernetes service and ingress for exposing our application outside of Kubernetes. We deployed our application using GitLab CI and CD functionality, and we demonstrated that the application continues to work even when you have pods that are deleted. So I appreciate everyone coming to this talk and taking the time to listen. I hope you learned something, and I hope to talk to you after this. Thank you.
Awesome, thanks Ryan. That was pretty cool. Kubernetes is a pretty incredible technology. It's amazing to see this stuff, and yeah, it's really exciting. So thanks for sharing that. I was introduced, my name is Matt Winchester. I'm a principal software engineer at Workfront. I work on architecture team, and specifically I work in the front end. So I do a lot of work with React and things like that, but I also sometimes venture into fun areas like microservices and stuff, which is what we're going to talk about today. So this is my 3rd time in Armenia, and I love coming to visit every opportunity I have. My children always get mad that I leave, but I'm glad to be able to come, enjoy your food, enjoy your hospitality, and I always love the opportunity to come to Armenia and see my friends. So thank you for having me here. So it's easy to see with what Ryan just showed us that you could very easily get an application that looks something like this. That is a universe of microservices, if you want to say that. Because it's so easy to make them, you could easily have a whole bunch of microservices that all depend on each other. And it's pretty exciting. But the thing is that comes with it, there's some challenges to having a microservice architecture, right? Just to name a few of them. One thing, if you look at this is kind of a complex graph. Now, I made this up, but it's actually not that far from reality, right? It'd be very easy to have, one service that relies on 3 others and another one that relies on it, and having these complex webs, it's not uncommon in a microservice world. So while any individual service may be easy to understand and work with and comprehend, which is a big advantage, the disadvantage is that you need to make sure that you can understand the model of the whole thing. And you need to understand your service's place within the complex network. Some of the other things that can be challenging is how you handle testing. Because again, you can test your one service and make sure your one service works, but you also need to make sure it works as part of a greater whole, right? So it's not going to be just your one service, but you also need to make sure anybody who's using it can continue to use your service with full confidence and without breaking. You also need to be able to, you need to be able to deploy new versions of it with people continuously depending on it and being able to make changes and updates and adding features, again, without breaking everybody who depends on you. And also local development can be a challenge when you're trying to get all the integrations set up. And we're not really going to talk about that much today, but it is an important one to note. So at this point, when you're looking at your network of microservices, you have a choice. Has anyone here seen The Matrix, the movie The Matrix? I guess it's an old movie now. Is that right? That sounds weird. I watched that when I was a teenager. But I guess it's an old movie now, which I guess makes me old. But that's okay. If you remember, there's the scene where he offers him the red pill and the blue pill, right? And so in this case, we're going to have a red pill and a blue pill. The blue pill, which is, if you remember, the one where you stay safe and you don't adventure into a brave new world. Where you try to do everything in a monolithic way. You try to say, you know what, we're all going to deploy all the services at the same time, and we're only going to test everything together. And that becomes an incredibly painful way of living, because you have to, like, let's say everybody here on the front row has a service, and we want to deploy. We have to go, okay, everybody get your finger on the button. Get ready. 3, 2, 1, go! Does that sound like a good idea to anybody? Does anybody want to do that? I don't. Okay, and same with testing. You know, if we're deploying one service here and it's adding a little thing, why do I have to run tests for way over there if they aren't related, right? So the monolithic approach, while you can do it with microservices, is extremely frustrating and not a good way to go. On the other hand, the red pill is that you pursue independent testing and deployment. And so, in other words, you figure out and you solve the problems around how you can deploy any service independent from all of the others with confidence that what you do will not cause everything else around you to break. So there's a few ways that we can do that. So at Workfront, we have a product that we launched this year called Workfront Library. Workfront Library is a document asset management tool that a lot of our clients use to upload their assets and to control and to be able to present to other people and receive feedback on. A lot of marketing departments. Anyway, that's not important. The important thing is that Workfront Library is actually built on top of AWS, which I assume all of us have heard of at this point. And AWS obviously runs lots of things. You know, they have thousands and thousands of customers that run on AWS to provide services all over the world at any point in time. So the interesting thing I want to point out here, if you look, I made AWS a planet with a ring around it. And if you look in this network here, there's a fair number of these things that are that same planet. In fact, you could argue that Workfront Library is more AWS than Workfront because of how many services we rely on as compared to how many services we wrote. We really do rely a lot on AWS's functionality to deliver the functionality of Workfront Library. So here's the question then. When AWS releases one of those services we depend on, do they run our tests to make sure they didn't break us? No, of course not. That's insane. That's ridiculous. If they did that, they'd also have to run all of the other tests from all of their other customers. They'd probably make you pay for it because that's what they do. But they would have to run all of them. And then if they broke, they don't know, like, is it because your tests are bad? Is it because we broke something? Like, they can't work that way. It's not an option for them. So they need to be able to deliver new features, new code, bug fixes to their platform without breaking all the people who depend on them, right? And this is an extremely real-world example of operating a service in production. So the question then becomes, how does AWS do this? How are they able to get away with deploying new services and the fact that Workfront Library hasn't had any significant outages ever since its launch early this year? We've had a few issues trying to get a deployment out, but we've never had any significant outage with it ever since we launched it, all relying on AWS services. And somehow AWS has been able to have hundreds of engineers working on the services that we use, deploying code all the time, and they don't break Workfront Library. So, how might they do this? Well, a few ideas. So the first is that AWS has very mature APIs, right? Now, I should clarify. I don't work at AWS. I don't have any experience working at AWS, so I'm guessing what they do a lot, okay? But I think these are pretty good ideas, and I think you'll agree with me, right? So we're going to talk a little bit about what a mature API means. They have good testing. I can only assume they have to have good testing. If they didn't have good testing, there's no way this would work. They have to practice good defensive consuming of other services, because almost certainly many of the AWS services depend on other AWS services to operate, and they have to be very defensive with how they do that. And then lastly, and I don't know that they do this, but I can't imagine how they do it without, is feature toggles are likely a very, very strong thing, and certainly a good strategy to use with microservices. Oh, sorry, there's one more. And they have a mature release and deployment process, which we'll get to again in a second. I don't know that they have the one I'm suggesting, but you get me today, so that's what you get. Okay, so what is a mature API? So the first thing I think of when I think of a mature API is that it's mindful of its breaking changes, that it thinks about like, okay, if I make this change, does that mean anybody who uses me needs to change their code in order to continue to use my service? Or will it continue to work without them doing anything? If they have to change their code, it's a breaking change, right? And so they use a version scheme, and they say, okay, well, I'm using this version, and as long as you're using that version, you should never have to change your code. And if you want a breaking change, then you as the consumer, choose when you upgrade versions, right? So, we might call it a major version or, a breaking change version, and you say, okay, I'm going to start consuming the next breaking change version. And you can make the code changes, and you can run the tests, and you can consume it when you're ready, right? So that's a big part of having a mature API. A mature API is straightforward to consume, right? I told you I worked in the front-end space, and I remember, like I said, I'm old, so I remember back in the day when the wars were between jQuery and MooTools, if anybody remembers some of those things, right? It was a long time ago. Like I said, I'm old. But a lot of the debate had to do with their API and how easy it was to use, right? An API that's easy to use is really valuable because it's a lot harder for developers to accidentally do the wrong thing. And so, again, a mature API should be one that it does what's expected of it, and it's easy to do what you want to do with it. They should be well documented, and this is kind of related to the last one, but you should have good quality documentation. AWS has a ton of documentation, almost too much, I think, in a lot of ways, but they have a lot of documentation. They're well tested. We're going to talk about that in a second. They're contract-based. The idea of contract-based development is similar to a contract. Let's say if a company contracted to build a building, right? In the contract, it would say, you're going to build a building, and it's going to meet the blueprints that we agreed upon, and we will pay you so much money, right? And then that's the agreement, and then the parties sign it, and then everybody lives by the contract, and everyone's happy, ideally. Well, in an API, you can similarly have a contract. People aren't going to sign the contract, but a contract can still be, hey, if you give me a request that looks like this, has a date and it has an ID or whatever it is that you need, if you give me one that looks like this, I promise I will give you a response that looks like this, or I will give you an error that looks like this. And you document out the contract, and you make it very clear. And a good contract people can develop against even if the service isn't available. Yeah, that's it for that one. Okay, so we want to talk a little about testing. Like I said, testing is absolutely critical. Really, I can't think of a place where it's not critical in software development. And certainly microservices are no exception. Unit tests are, of course, like the first place that we start when we talk about testing. The importance of developers writing unit tests on their code, on a class, on a method, on a function. But when I say unit testing, I mean really good unit testing. Like I don't know what it's like all the places that you work. But I know that I have seen experiences of really good unit testing, and I have seen experiences of kind of good unit testing, right? A lot of times, what I've seen developers, they look for code coverage, and they look at a code coverage statistic and they say, oh, I hit 100% code coverage, I'm good. But the truth is that code coverage is only the first step. If you don't have code coverage, well, that's bad. We know that. But just because you have code coverage doesn't mean it's good, right? So an example, there's internally at Workfront, we have a design system. We call it the Phoenix design system. And inside there, I remember seeing a pull request come in recently where somebody wanted to add a new prop to a React component. And in there, they didn't have any new tests to cover how that prop was supposed to work. Now, they still had same code coverage. Code coverage stayed good. But I said to them on the pull request, I said, don't you want to add a test to make sure that this works? How do you know someone's not going to break this in a month when they change something else? Like, you should put a test in there to make sure this functionality you cared enough to write a pull request for continues to work in the future. And so, to me, a really good test looks beyond code coverage and looks at, did I exercise all the cases? Because really a good unit test is a defense. A defense saying, I don't want this to break ever. Okay, this talk isn't about testing though, so I'll move on. Okay, contract tests. So we talked about contracts. And so you actually have a test that exercises your specified contract. Do I always honor and obey the contract? You can have consumer tests. Consumer tests are ones, and this works well more internally inside of a company. But what you can do is you can have somebody who uses your service, they can actually submit to you with a pull request a test to add to your suite. And they annotate the tests saying who added the test. The reason why you might do this is, let's say that I'm working on a service and I'm doing some development, and you send me a test. And now in my development, that test breaks. Well, now I know I need to do one of two things. The first option I have is I can fix it so it's not breaking, and then I know I'm not going to break you, right? The other option is now I know that I'm going to have to break you, and we can go have a conversation, and we can coordinate, and it won't be a surprise for you, because that would just be terrible, right? So that's the idea of a consumer test. It's a nice, powerful way of forcing communication and making sure people don't get surprised. Okay, and then finally, performance testing can be very important because, depending on the needs of your application, but microservices can come under a lot of load, and sometimes, the contract you put out, you might end up violating under intense load. So it's also important to performance test your application, and that will be relative to the needs of what you're doing. I talked about a defensive consumer. How many have heard the phrase, the best offense is a good defense? Anyone heard that before? Okay, I know that's something I've heard before. I used to play soccer when I was young, which I think you call football here, but I called it soccer growing up. And that was I played defense, so I liked this quote a lot. But there are some things that you can do in a microservice architecture to be defensive. So one of them is you make plans for if your dependencies fail, right? So in Workfront Library, perhaps we're depending on, let's say, Amazon S3, right? And there have been a few times, not many, where Amazon S3 has gone down. Now, like half the internet goes down when that happens, so it's no surprise. But at the same time, it is something that you want to plan for. So maybe you throw an error and you say, I'm sorry, I can't honor your request. One of my dependencies is down. Or maybe you have a cache that you work out of while this other service is down. It's going to depend on your situation and what your needs are. You also want to handle any error conditions, which again, a good contract will help you know what the error conditions are. And so you can prepare for every single error code that you could possibly receive via the contract. Okay, I want to talk about feature toggles a little bit. We talked about this one. Feature toggles are a really simple idea, right? I mean, I assume, if we're talking about software, we're all familiar with the idea of an if statement, right? Ifs are like one of the most fundamental pieces of coding, right? They're all over our code. The idea of a toggle is very simply, you have, if I turn this feature on, then you do it. Else, I don't do it. I do whatever I did before, right? So maybe you're introducing a new button to your page. You wrap it in an if, and you only do it if your toggle is on. And then you can use either an internal service or an external service for managing whether that's on or off. So it might make a call out and say, hey, is the feature on or off? And it allows you to control your features without doing new code deploys. It's really powerful. It can also allow you for continuous delivery to deploy things. Well, here we go. You can, if you're deploying something that's breaking or maybe is incomplete, you can hide it behind a toggle. If you want to run a pilot or an A/B test or something like that to gather feedback, it's a good way you can do it, and the toggle can allow you to only give it to a controlled portion of your user base. You can use it to test in production. That sounds kind of scary, doesn't it? But you can actually do it, and with confidence, right? So at Workfront, everybody who logs into Workfront, they all have a tenant ID, right? And so, sorry, I get distracted easily, but they all have a tenant ID, and at Workfront, we have a few tenants for ourselves that we reserved for testing purposes. So I could actually just turn on the feature just for our tenant. It's still running in production, on production infrastructure, but none of our customers see it. And we can test it, and we can see how it performs on real production infrastructure. And this is probably the most powerful thing, and really kind of the central point of my talk, the title of my talk comes back to, is that it allows you to decouple release and deployment. Now, what do I mean by that? Because a lot of times people think release and deploy are the same thing, but they're not. They're different things. So when we talk about deployment, deployment is when you take code and you put it into a service. That's what Ryan demonstrated for us. He had a service he had written, and he deployed it to Kubernetes, right? When you have a feature that you decide that you want to start showing to your users, that's called a release, right? And we make this distinction precisely because we want to decouple those things. We want to deploy code constantly without having to worry about releasing new features. And we want to release new features without having to worry about deploying new code. There's a golden rule of feature toggles, though, because feature toggles are a blessing and a curse. Because if you have too many, you will you'll be crushed underneath the weight of them. That didn't go the way I thought. And the golden rule that I promote is that you only have as many as you need, and no more. And you only for as long as you need, and no longer. And that's a pretty good rule to start with when you're looking at how many feature toggles you should have. All right, so let's go through a theoretical scenario here. This is kind of the main point of my talk. So we built up all this so we could get to this, talking about atomic release and deployment, which is the model I'm proposing. So let's pretend this white planet here is your service that you're working on, and it's really important to you. And it's gonna make you all the money in the world, and it's just so amazing, and you're so excited to be working on it, right? I would argue your service is made up of 3 parts. The first part is the code. And this part's pretty obvious, right? This is what runs and it's what handles your requests and gives responses. If you don't have this, you don't have anything, right? The next part is the configuration. And this can involve a lot of things. This can involve credentials for cloud services. This can involve connection strings for databases. But it can also involve, and very importantly here, it can involve the state of your feature flags, right? Whether they're on or they're off. And finally, the last thing that I would argue is part of your service is your test suite. And in this case, I drew it off to the side like it's a moon, you could imagine, orbiting it. But little more than a moon, more like the Death Star, where it's got like all sorts of weapons on it because it's a defense system. Anything that would want to hurt your service, your tests are going to protect you from it, right? So we're going to walk through a few scenarios here. So let's say in an atomic release and deployment model, I want to deploy new code. So what do I do? So in this case, like I said, it's made up of 3 things. So what you could do is you could spin up a new environment, and in that environment, you could run a test with the same test suite, with the combination of your new code and your current configuration. Now, I say that a little hand-waving because you may not connect to the same database. You might have to do some of that part of the configuration different, but the part you definitely keep the same is the feature toggles. So you go ahead and you run your test, and assuming that the new code passes the test with that configuration, Then you go ahead and merge it and you deploy your service with the new code. Deploying configuration is largely the same. Only instead of changing the code, this time we change the configuration. So now we stand up a new environment. We run the currently deployed code against the proposed configuration with the current tests. And if they pass, great. We can deploy the new configuration. Maybe we're turning on a new feature. Okay? The last one, and this is a little different, is if we wanted to do new tests. Now, typically, most services are deployed across many deployment lanes. You might have a production lane and a staging lane or something like that. At Workfront, we even have a lane that's just dedicated for our own private internal instance that we use to test our features because we use it for our own product in our own daily work. So, in this case, what needs to be done is your new tests not only need to work with this lane, but they also need to work with this lane and this lane. So if your new test suite can work with all current configurations, then you can accept it, and it's a good test suite. This is what we mean when we say atomic. Each of those operations, deploying code, configuration, and tests, are independent, and each of them can either succeed or fail and be rolled back apart from each other. That's what we mean when we say atomic. So let's talk a little bit about this test suite, because this test suite has a little more to it than what I've just shared with you. Let's pretend for your service you have a test suite and it has 5 tests in it right now. Okay, that's probably not enough tests, but we're just going to say 5 tests for now. And that now you're going to write a new test, and this test is introducing a new feature. All right, you can configure your test such that the test will only ever run when your feature toggle is turned on. So in other words, and we'll get to an example here in a second, but if you run it when it's only turned on, then that means essentially the same as your code when you haven't turned it on. Your test is dormant, is dark, is hidden, and your test won't run until activated, which is really nice because you can basically have things in place to say, hey, right now, don't worry about it if it's broken because we're still working on it. But if you ever try to turn it on, now you have tests that make sure that your new feature is actually working. So, we're going to go through a quick little scenario here. Let's pretend your microservice has currently code A, config A, and the test suite A, and everything's passing and perfect, right? We want to start from a good state. Okay? Now let's say, like we said, we're working on a new feature. So we introduce a new test for it, but we haven't introduced code and we haven't introduced config. Remember, that's key to Atomic. We change one thing at a time. So we add the new test, but of course, because it's configured to be off, of course the test is going to pass. It's dormant, like we said before. So we go ahead and pass that one pretty easily, introducing the new feature. Let's say then we have maybe a product manager who's in charge of the toggle, and they get overzealous and excited about turning on this new feature, and they go ahead and try to turn it on. So they go ahead and hit your system that allows them to turn it on, and because it's a good system, it runs the test before it actually applies it. And so it tries to run with this new configuration. But because now with the new configuration it tries to turn on the feature, your test is failing because we haven't deployed any code yet. And so, as the test should, it fails. And it says, you should not apply this configuration. And because you're using a good system, it automatically rolls back to the previous known good configuration. Okay? So once you do this, then you can now, let's say, we actually did finish the code, and we're ready to deploy the code for this new feature. So we go ahead and deploy it. Now in this case, the code is dormant and the test is still dormant, but we're able to deploy successfully because we didn't break any of the previously enabled tests. Notice the new feature is still off. And then finally, now that the right code is in place, we can turn on the configuration, which activates the test, which exercises the code, and when we get the thumbs up, we're able to turn on our new feature. Now this is a lot more steps, but it has a lot of big advantages in that we can do a lot of these things independent of each other and with confidence. And especially in a world where you're dealing with lots of different microservices, that can be pretty important. So this is the atomic release and deployment model that we're adopting at Workfront, and I wanted to share it with all of you here tonight. So with that, that is all I had for tonight. So thank you. do we do a Q&A now? How do you want to do that?
Yeah, we can do it. So anybody have a question? I can hand in the mic. Come on, nobody wants to go first?
And questions for me or Ryan too, by the way.
How you are managing when you toggle the new feature, how you manage to automatically run the test which is specified for that feature?
So you're saying when we try to apply the new configuration? Yeah. So there's a lot of different ways you can do it. At Workfront we use GitLab a lot. So you can make there's a few ways you can do it. You can make a new job that runs the tests under that new configuration and check that it's green. And when you see that you get that green check that Ryan showed you before, then you know that you're good, right? There's lots of different ways, however you run your tests, you just basically want to run your tests and with that new alternate configuration, and then you'd save that configuration and if successful, apply it. Does that make sense?
Thanks.
Any other question? No? Okay, we still have time for socializing. So enjoy the food and thank you for coming.